Okay, hi everyone. So I am one of the group members for the investigating seismic wave speed from an Alaska earthquake. These are my group members, Alton and Michael. And so basically the premise of this whole project is we like to model seismic body waves, P and S waves, as these like things that expand uniformly radially outward, as we can kind of see in this GIF over here. But that's not really true in real life. There's a lot of different things that will change the velocity of seismic body waves, and we wanted to look into that. There's a lot of applications for this. One could be like early warning systems. You might not expect something to come as quickly as it does, and then you would be surprised. So definitely a lot of cool stuff to look into here. A little bit of the science behind this. So for seismic body waves, these are like the first couple waves of the earthquake. The most destructive ones are the surface waves, but the seismic body waves kind of provide a warning almost. We start out with a P wave, which is this one where you just basically compress and then expand and compress and then expand. And that's the fastest. We then have a shear wave, which is larger in magnitude and travels a little bit slower. And for the earthquakes that we study, because we just looked at some in Alaska in a relatively small spatial scale, they'll propagate along the crust right through here. So how did we do all of this? We started out by accessing QuakeML files from the Alaska Earthquake Catalog. It's a very high quality data source. We'll go into it in a little bit, but there's a lot of seismometer stations, and it's very high temporal resolution, so it allows us to see with great detail where the earthquake is. From this data set, we then identify seismic events of interest. In our case, we looked for a high number of, they're called ticks, which is when a seismometer picks up the earthquake and like indicates that it's at a certain location. And then we built some data frames containing all of these picks, and then we plotted them and thought about their significance. So just to give you an idea of kind of some of the data that we looked at, this is a plot put together by our group member Alton. You can see these are all of the earthquakes in the Alaska Earthquake Catalog in 2019 January. And you can see there's quite a lot of them. They vary in magnitude, and there's some interesting clustering going on here. And just to talk a little bit more about the quality of the data that we used, here is a station map. You can see, especially in the region we studied over here, you can see very high clustering of all these seismometers. So that improves our confidence for some of the interpolations that we were then able to make. So here is kind of one of our final products. This is a single 5.2 magnitude earthquake on the 22nd of January. And you can see first here, you can see the P wave in blue is propagating out rapidly. And then you can see the S wave here is lagging behind it. And all of these are interpolated onto a 2D grid. And so there's some interesting trends. We can see the S wave propagates relatively quickly down this trench along the Aleutian Range. And there's a lot of reasons why that could be. From our review of the literature, it looked like it might be due to that being a subduction zone where there's going to be a lot of rock under a lot of pressure. And then additionally, there's going to be an accretion area where there's a lot of sedimentation. All of this is going to decrease the porosity, which will increase the speed at which the S wave is able to travel. So we did some further analysis, and here, this is again for that 22nd of January event. We have travel time plots, so you can see the number of seconds here, again, using the interpolations. And then the epicenters here, obviously. And you can see, based on the contour spacing, you can see that there's some asymmetry here. So we wanted to see if this was a trend that was consistent between earthquakes, right? So we aggregated 10 earthquakes in the same lat-long 1 degree box, and then got the azimuthal mean velocities of all of them. And you can see there were some data issues. There's a lot of like suspiciously slow earthquakes, which is definitely something we want to look into further. But you can see there is an interesting asymmetry here. And I think that is an area that we've identified that we're going to want to go in after this project and after OceanHackWeek. So that's pretty much it. Just like to say thank you, everyone. It's been a great week and great opportunity. So thank you.
Great, thank you. Okay, next up we have XYZT.